Alright, so today we're going to finish working on our tests for some people, so you got to finish. If I gave you a test, that's your one and only thing you need to do for sure 100% today. Done, because this is the third day we're doing it, especially if you have a terrible habit of being on your phone. No names. So, we are going to work on volume today. Okay, so we're moving past surface area into volume. Okay, so volume of all types of figures, but today we're going to focus on prisms. Wait, hold on. Back up. Not prisms. Cylinders and cones. Okay? So, we want to make sure, like I just got done saying, that we want to put this junk away. Put this right here. Right? Right? I'm going to grade what you have done today. Okay. Alright, so let's look at our notes. This sheet right here, okay? Yay, look at me. Alright, so I had to do that. Now, let's write this down. This says, comparing the volumes of cones and cylinders, our objective is to discover the relationship between the volume of a cone and the volume of a cylinder, the volume of a hemisphere, eventually. So number one says, what are the formulas for the volumes of a, and it says cone and cylinder. Now, if you're wondering where we're going to have these in the future, remember our formula chart that looks like this. It's going to be on there where it says volume near the bottom. Okay, so you don't need to see that right now. I'll tell you what it says. For a cone, it says V equals 1/3 capital B H. So V equals 1/3 BH. We're all writing this down. And then for cylinder, it's similar, but V equals BH. Okay? So we got 1/3 BH, and then we got BH. All right? Now, what do each of these represent? So what do you think, take a wild guess, what do you think what do you think V stands for? Volume, duh, right? That's the name of this note sheet. So let's write that down. V for volume. And then capital B, what did it stand for, and it still stands for? Capital B. Okay, what about the base? No. Area of the base, right? So remember, big B, capital B, area of the base, and then H, of course, height, right? Now, this next part is the kind of interactive part. So it says, what is the only difference between the formula of the volume of a cone and the formula for the volume of a cylinder? So you tell me, what's the only difference you see? 1/3, because they both have BH, but 1/3 is missing, right? So, cone has 1/3, cylinder does not. Okay, something to that effect. The cone has 1/3 in it. We should be writing this down. Cylinder does not. So we have, like it says on number 4, locate the plastic cone and cylinder. I have located it. They're in my hand. Yeah? Located. That's what they look like. Okay? So these are the ones we used on the 3D Nets assignment, so they're not too new. It says, what do you notice about the bases of the two solids? Okay, now, class, looking right here. So, what do you notice about these bases? Are they the same or are they different? So, like you can see that they are, the word is flush, but they don't go past each other, right? They're exactly the same. So, the answer to 4A, what do you notice about the bases of the two solids? They are the same, okay? And then for B, how many cones full of, and we're going to use beans instead of rice. All right? It's okay because it's Fiesta Week and we like beans, right? So how many cones full of beans do you think it will take to fill the cylinder? Okay? Now, look right here. Okay? I think these are called lentils. Okay, we got a bag of beans, little tiny beans. Okay? If you want to see what it looks like, little lentils, L-E-N-T-I-L-S, little tiny beans. Okay? If you can assist, that'd be great. So, we have these little beans, and what I'm going to do, like it says, is I'm going to try to fill the cylinder with cones worth of beans. So, let's take a guess. Okay, so we're going to take a poll. All you got to do is raise your hands. Is everyone listening? Looking over here? So, how many, if I fill this cone up and pour it into the cylinder, how many times do you think I can do that? Okay, so who thinks 2 cones fill a cylinder? Raise your hand. Okay, I got a hand or 2. Okay. Who thinks 3 cones will fit in a cylinder? Couple hands. Now who thinks, all right, good. Who thinks 4 cones fit in a cylinder? Who thinks more than 4? Okay. So, let's do the experiment. Now, last time I ended up spilling the beans. Hey, it's better than cutting the cheese though, right? All right, so here's the deal. I'm going to take my cylinder and I'm going to really, really try not to spill this. Let's see how this works, okay? So, all right, so here's, y'all agree this is about 1 cone full of beans. I'm going to pour it into that cylinder, try not to spill it. All right, now, as you can see how many beans are there. So, all right, that's 1. Let's do another. Any of y'all go to Fiesta last night? No? All right. I was there. I had a gordita. Gordita. All right. This is where the spill happens. Don't spill. Okay. I know. All right, so we got another cone. Oh, just a little spill. All right, so check it out. So that's 2. Whoever said 2, I'm sorry, it's not 2. Okay, let's try 3. Let's see if it'll work. All right, here we go. All right, so we got my 3rd cone into my cylinder. Okay, let me just try to even it out. And look at that, all the way to the top, full of beans, okay? Now how many cones, drop it, is that what you said? Now how many cones filled up the cylinder? 3. All right, so, very good. So do y'all see the visual? 3 cones filled up a cylinder, right? So I'm going to pour it back in without spilling it. All right. Only slightly spilling it, actually. It's whatever. All right. All right. Every class. All right, so that's fun. Now, let's go ahead and fill this in at the bottom. So how many, the question we had was it 2, was it 3, 4, or more? I don't know. But on 5, here's where we did the experiment. We filled it up with beans, right? And how many, the number of times it took, what are we going to put for this blank? 3, right? So write that in. So in conclusion, and let me make this look nicer. This is a 3 and a 4. All right. So in conclusion, the volume of a cylinder has blank times as many volume as a cone. So a cylinder has 3 times as much volume as a cone. But I want y'all to notice, it had to have the same base, right? So it was the same base, but not only that, but it had the same what? Height, right? These are the same exact height, same exact base, okay? So let's write that in. The same base and height. So that's saying if you have a cylinder that's 3 times as big as a cone, but what about the other way around? A cone has how many times as a cylinder? So backwards, instead of times 3, it'll be thinking of opposite of multiplying, dividing, so it'll be a fraction, 1/3, okay? So 1/3 times as much volume, but only if it has the same base and height. So once you have that written down, you can flip it over to the next page, please. All right, so here we are. We're doing the examples on the back. So what is number 1 here? What is that? A cylinder, right? Now, when we're doing this, when we have big B, what is the shape of that B? What is the shape on a cylinder and a cone? What's that shape? So, big B, area of the base. We said the base is a circle, so you need to know how to find the area of a circle. Now, on your formula chart, okay, up here at the top, it says area and then circle. If you did not know this, the area of a circle is pi r squared, right? Pi r squared. So big B equals pi r squared. This is going to work for every time we have a circular base. Okay, so keep that in mind as we do this. So what is our formula for the volume of this shape? Again, we call it a cylinder. So what's the formula for cylinder? Let's go back to the first page. It is BH. Let's write that down. Now, I'm going to replace B with, at the top, we just wrote it down, pi r squared, okay? You got to know when there's a circular base, capital B, pi r squared. So, pi r squared h, and off to the side, what is r? What is h? So what is r? 3. And what is h? Okay. So pi 3 squared 4. I'm going to put these in parentheses, okay, because we're plugging stuff in. We're substituting. So what we're going to type in, pi 3 squared 4, and that'll give us our answer, okay, which is not too hard. You just got to know what capital B stands for. So we go to our calculator. So again, what was it? Pi 3 squared 4. So we get 113.1. Now, the units are feet, right? Here's the question. For volume, feet what? What am I going to do to those units? Okay? So, y'all remember how dimensions, length is normal, area or surface area is squared. Now this is volume. This is the next dimension, right? So you'll be enjoying maybe Avengers on Friday with your 3D glasses, seeing the depth. I did spill the beans again. I'm sorry. So, but you get the idea. 3D. So the 3 implies that instead of a squared, we're going to have a 3 for the exponent. Okay? Now, I want you to know how to say this. So here's how you say this. Feet cubed. Not squared, but cubed. Okay? So the little 3 means cubed, right? You could also say cubic feet, just FYI. Okay? But we're going to say feet cubed. And we are on this page right here. So, that was not too bad, right? Now, going from here to letter B, we're going to think, logically here, it says what is the volume of a cone with the same base and the same height? Okay, so this brings us back to our bean exercise. If I have a cylinder and I'm trying to figure out the cone, what do I do to this volume to get this volume? So let me remind you at the bottom of the front page. So if we have the volume of the cylinder, okay, and we're looking for the cone, we do 1/3 of the cylinder, okay, which basically means we're going to divide it by 3, okay. So here's the logical way to think about it, okay. If you have the cylinder and you're going down to a cone, think of down, you're decreasing it, you're going to have to divide by 3. So let's do that. 113.1, sorry, divided by 3, that will give us the cone if it has the same base and the same height, okay? So I go to my calculator, divide by 3, and I get 37.7. What are my units going to be for that? Feet cubed, right? Feet with a little 3. Feet cubed, all right? Okay, next one. So, what is the shape of this next figure? Number 2. Got a cone. Now, the formula for a cone is what? Is it BH? So we go back to the front. So for a cone, it's 1/3 BH. Okay? So don't forget the 1/3 if it's a cone. Now there's a problem here. For B, we need to do pi r squared, right? So 1/3 pi r squared h. I know what my h is, but guess what's missing? The radius, the r. So, hopefully you notice there's a right triangle here. Anytime I have a right triangle and I'm missing a side, what do I use? Pythagorean Theorem, okay? Now, notice, I'll do this in a different color here. So, 24 is pointing to this. So, 24 is this height, right? And if this slant height is 25, then this slant height over here is also 25. So we are missing x in that right triangle. Okay, so does everyone see that right triangle? Okay. All right, here we go. So let's do Pythagorean Theorem. A squared plus b squared is c squared, right? Equals c squared. I want you to notice, and this I beg you to pay attention to this. If you have a missing leg, like we have right here, right? One of the sides of the right triangle, you have to set it up correctly, okay? A and B are 24 and x, right? So here's how I would set it up. 24 squared plus x squared equals 25 squared. Okay? Do you see how the 24 and the 25 are not on the same side? Right? The legs are on the same side and the hypotenuse is on the right side. So I need to figure out what's 24 squared and what's 25 squared. So let's do that real quick. So 576 and 625. Whatever. Okay, now, next step. Notice how on the side with x, I have 576. I have to subtract it to get it to the other side. We always do the opposite, so minus 576. $25 minus 76 gives me 49. And what's my last step for Pythagorean Theorem? Square root. So what is the square root of 49? 7. Okay? So all that work to figure out this radius is 7. Okay? Now, on your assignment, you're going to have to do this a couple times, so make sure you're following along. So my R is 7. We just figured that out. What's my H, my height? 24. It's sideways, but that's all right. Okay? Now that I have R and H, I can do this. So I'm just going to plug it in. I got 1/3 times pi times R squared, 7 squared, times H, which is 24. Okay? All I got to do is plug all that in, and I'll get the answer. Okay? I know. So let's do this together. 1/3 pi 7 squared, 1 divided by 3 times pi 7 squared times 24. And I get 1,231.5. And my units are inches cubed, right? Third power for volume. For letter B, so it's going to kind of be backwards from the last one we were doing. This is finding the volume of a cylinder with the same base and the same height. Now I want you to notice, this time you're going from cylinder, you're going from cone to cylinder. So you're going from small to big. So are you going to multiply or divide? If you're getting bigger, you're going to multiply, right? Because there's 3 cones in a cylinder. So we're going to take that cone volume and multiply by 3. So we get 3,694.51. And my units are going to be inches cubed, right? Cubic inches, however you want to say that. All right? Now, another softball, okay, because I think these cylinders are a little bit easier. Do we know R and do we know H? So, R is what? 4. H is 23. What's the formula for the volume of a cylinder? V equals what? Good. BH. And remember, capital B is pi r squared. So pi r squared h. And then we replace r with 4. Pi 4 squared. H is 23. And then we go to the calculator, plug it in. One 156.11. And my units are centimeters cubed. Okay? And just like number 1, how do I go from a from a cylinder to a cone with the same base and the same height? What do I do with 1156.11? Multiply or divide? We're going down, getting smaller, so we're going to divide by 3. And we get 385.37. And those units are going to be centimeters cubed. Okay. Last one, real quick. This is another one where we need to use Pythagorean Theorem, so we're going to do that fairly quickly here. 22 is over here. 14 is my radius. Cool. But I'm looking for my height, right? Height is x. So guess what we do again? Pythagorean Theorem. My legs are x and 14. So I'll do it over here. X squared plus 14 squared equals 22 squared. I need 14 squared and 22 squared. 196, 484. Okay, so I squared my numbers first for Pythagorean Theorem. And then, just like on number 2, I need to subtract because I'm missing a leg. Minus 196, minus 196. That should give me 288. And then the square root of 288, it rounds to 17, okay? So my height, my h that I got using Pythagorean Theorem is 17. So let's use the formula. What's the formula for a cone's volume? Is it BH or 1/3 BH? 1/3 BH. And that's really 1/3 pi r squared h. Which is really 1/3 pi 14 squared times 17. Okay? We'll type it in, and we'll get our volume. So 1/3 pi 14 squared 17. I get 33,489.26. And my units are meters cubed, right? So that's pretty big, and then guess what? We're going from cone to, once again, up to a cylinder with the same base and the same height. So what do I do to this number? Do I multiply it or divide it? Multiply by 3. Okay? So it's going to be a very big number. And I get 10,467.8. And again, it's meters cubed. So, kind of like we did on our last assignment, again, Avengers comes out this Friday. We get to Hulk our papers. We're going to separate them, not tear them in half or anything, but separate them at the staple, because the second page is the one you're going to need to finish and turn in, the one that says assignment. Okay, so the one that looks like this, the one that says assignment, volume of cone and cylinders. So make sure you're working on that. It's only 6 problems on one side of the paper, but, you want more? I know. Please be careful with number 3 and number 6, because you will have to use Pythagorean Theorem, okay? If you get stuck on that, let us know. But please work on that today, and tomorrow we move on to the next volume thing.